So thank you for coming back to us, and thank you for agreeing to have a little chat about the Skills Bootcamps and your progression since, and how Supernova Labs are progressing with that through your drones, through your ability to speak to clients. So it'd be good to hear a few things from you. I've just got a few questions about why you did the bootcamp. Did you enjoy it? Do you feel you've had value? But next steps, obviously, I see you around the space and aerospace sector. So I'll start with the questions, but it'd be good if you just want to give us a bit of an overview. Who's Supernova Labs? What do you do? You know, that gives an understanding of what brought you to the Skills Bootcamps in the first place.
Yeah, no problem. So Supernova Labs, we are a community development lab in the south of Manchester. We focus on specifically our advanced technologies, so 3D printing, building drones, virtual reality, aerospace and space industries. So this is one of our major focuses is advanced manufacturing and how we can apply that to improve processes for aerospace, but also, I'm hearing a bit of an echo.
So where was I?
Supernova Labs
technology, and yeah, at the minute we're building drones. We're looking at space planes in the long term.
Yes.
But how do we get to a point where they are 3D printable at the scale of a traditional fab lab?
Yeah, brilliant. And I think it's interesting you talk about all those advanced manufacturing technologies, Industry 4 technologies, VR, AR. I think they're easy bits for people not to see. You know, they'll see the physical output in that way, but not how you go through that, how that might involve computer simulation and all the prep work, all the calculations you do beforehand before we can have a physical product. So I think that's really interesting to hear about that as well. What jumps out at me, I think it's brilliant. You're talking to me as an Supernova Labs. I think, you know, SpaceX has really sort of advanced that. The preconception is you need to be NASA, you need to be, you know, all these big engineering companies. But the reality is you don't. I think it's really open source. I think we can really advance these technologies because we have that flexibility and freedom that perhaps the bigger organizations don't have.
Well, I think that's one of the benefits of, as you're saying, like all this open source work, because I think traditionally aerospace has been quite a lockdown industry, and this has been evident in the way we've had to approach speaking with clients and speaking with partners in industry. They've often been quite closed door, and they've not wanted to share their work because it's national security infrastructure. Whereas the open source community in other industries has been making ground at getting people to maybe open up their processes a bit more, share their designs. If we can put designs out there that almost clear the road for them to see that it's de-risk that whole process of, oh, we can put this out there and there's not going to be massive backlash in terms of like ITAR requirements or like specifically like loads of people stealing our work, because actually what ends up happening is people end up building on our work and we get the benefit of that work as well.
Brilliant. And it just shows how much you can multiply that, you know, and great examples, things like Firefox and Oxprint for 3D printing, great examples of user-led systems that have really become the norm in the mainstream. You know, again, SpaceX with Tesla, you know, with Elon Musk, really showcases really that traditional industries who have been associated with these technologies don't need to be anymore. You know, it is becoming to everyone.
Well, there will have been a point in time where like motorized vehicles and all this were like part of military and part only really for that kind of world. And as time has gone on, the technology has developed and become more distributed throughout society. Like I personally would like to see a world where both of us could just jump in our car and go to space.
I love that. And obviously you're making really great strides towards that. So, you know,
so. Thank you for
the community involved in Supernova Labs. Brilliant, really excellent work. Obviously, I see some of what you're doing through STFC and Darsbury and some of the aerospace trade body. But it'd be good for you just to share a little bit of that with us, what you can do, obviously without giving anything away you shouldn't. So I'll just ask a couple of questions relating to the boot camps. I know you came through our Greater Manchester Skills Bootcamp in Wave 4 as an independent learner. But as we can see, the subject matter you're working on is really impressive, but it's great to see that community. It's not just you're greater than your numbers in strength and ability.
Yeah, absolutely, yeah.
Which is just really encouraging. So what made you decide to do a skills boot camp? How did you feel that? What took you, what was your journey to that and making that decision?
So I came out of Fab Labs and Maker Spaces. I used to run co-working spaces in central Manchester as well. I understand like small workshops on the scale of like, a few users building, like working with laser cutters and 3D printers at that scale. Yeah. But when it comes to much larger manufacturing, as I was saying, I've kind of struggled to work with aerospace manufacturers to get the information I need to work out how to construct like the production lines, how to even how do you even approach this? What technology goes into it? And part of that whole skills bootcamp, alongside being recommended by the local hackspace, Manchester Hackspace.
Yes.
I saw a lot of value in that because obviously you guys have experience with that. There's a lot of information in that skills bootcamp about how to set up production lines, what goes into it, how do you do safety gating for all your robotics. Like that is all really key information for me going forwards when we scale up to that scale.
Outstanding. So a little bit of a kick on, really. You had quite a bit of knowledge already, but I think it just helped me take that step up to the terminology and processes, the bigger, more industrial processes as you up, and maybe one day we can jump in the car and just
maybe one day.
So it's really good to understand that, because that's great feedback. That ability to there may be a core knowledge, but then you can build on that into industrial processes.
Well, that's it. Now I can look at, because I think there is a lot of information out there about like jet production lines and about like spacecraft satellite production lines.
Yes.
But now I can look at something more critically and say, like, look, okay, but this is how they're approaching that, and this is how they're breaking it down into stepwise processes, and I have a much better understanding looking at something enough to emulate it now.
And I think it's good to see that, we talk about lean processes as well. There's some really great best practice in that for how those production processes work around, say, automotive, that we can really use that best practice in the space sector and the aerospace sector. And I think see that you've identified that already as, there's some really good learning away from almost the core subject and onto manufacturing and those ancillary processes around it. That's brilliant, Adam. So did you enjoy it? Do you feel you got something out of it? And are you using those skills from your course? I know we spoke about the drone production.
Yeah, of course. So
maybe you can tell us a bit about that.
Yeah, well, I love the course. I mean, I just I enjoyed like going through. Like, again, it's just getting in. I am so I'm maybe bad for it. I spend a lot of time watching YouTube videos about like, my subject area, just so I know as much as I can about that. And having somebody that's been through that and like can point me in the right direction and give me almost context on what's available, because when I'm working in things day to day, like, I don't have the time to like be looking at manufacturing and all of the things that are going into that to know what's on the very cutting edge. So coming into that boot camp, I've learned a couple of things about how I can approach this differently and things that I didn't even know what were possible before I even started. But in terms of what I've gained from it, I mean, I've been building loads of stuff. So I mean, this is what was the drone before it crashed its first test flight.
Outstanding. Unfortunately, you can just 3D print another one. So these have been multi-billion-dollar projects, and
I've realised I've overprinted this. So this is it's just way too heavy for what I need. So I think I need to scale that back. Well, I used 2 wall thicknesses instead of 1. That's the next step, is just like using that. Like, how do I harden that up? Like maybe with a layer on top of it.
Brilliant.
Maybe 22 motors in that, but that was printed on the printer that I got from the program.
Just outstanding. I think it's really good to sort of outline that. Really, the hardware we give to learners and learners build and get used to operating. It's not inferior hardware, it's production intent hardware. the lower end of the spectrum, but that's because a lot of it's quite manual, and that really brings the skills you need to then use that formally or go on to, you know, more automated processes. Understanding that the principles of it is really important to.
Well, to put it in perspective, so I'm part of my local hackspace, so as I was saying, the Manchester hackspace. They've got like 2 Prusia Mark IVs and an XL there, and yet I still choose to print on these Ender 3s because I like being able to like get in there. Like if something breaks, I know why.
Yes, it's those fundamentals, and I think that's a brilliant endorsement. We're still really fond of them. We have access to industrial machinery, but our go-to printers are still the Ender 3s because fundamentally they're easy to control. We know what if something goes wrong, it's really easy to identify that. Really efficient, cost efficient to replace a 50 pence or a piece of Bowden at a few pence, and that's really important. I think that's really important feedback for people who are looking at doing this course as a production intent process, that this is the tool you can use, you know. So
well, especially like when you think about how it can be upgraded. So I've already upgraded the base on mine to the stuck down magnetic version. I was having issues with the bed moving around with just those clips, which is I think that's just part of the process, but I think the scale I was printing at was beyond that. So
I think it's part of the process. And pardon me, it's part of the process. And when you talk about, it's interesting you talk about the drone and the strength of it versus weight, the biomimicry, the lattice structures in there, and the ratio between the shell externally and the infill internally is what really gives you that strength, that strength to weight ratio. We still have our support clinics if you want to, and we offer that ongoing support. If you want to dip in and just do a little bit of a chat with the engineers about how to maximize that strength to weight ratio, obviously we're always happy to help.
Yeah, I'd love to come in and
you know, and it's brilliant you mentioned that bit of biomimicry that we use, effectively mimicking the structure of the bones with a very thin outer wall and a lattice structure creating the strength. It's how we do that, you know. So we can help you with that, and it's brilliant to see the drone. I mean, that you know, space intent drone looks.
Yeah, cool. Well, I think the point of this was really as a pathfinder initially, just to see like there's a few things I needed to learn like without it even flying. Specifically, how long does it take to print one full drone?
Yes.
How much can I fit on individual build plates, and how do I need to segment that in future? And yeah, so I've managed to work out I can print one a week. Across I've got two printers here, so across those 2 printers, I could print one a week, and I think it's like 4 or 5 build plates I can fit the whole lot on. So I don't need to, and it all fits well. But when I go on to design and the next version of it, I can now take all those learnings into it as well.
Outstanding, and I think that really brings us on to asking about next steps. You're already sort of iterating now because you can. Those production costs are right down. That enables you to change that design and iterate to really get the best design, which using things like traditional injection molding or outsourcing that wouldn't potentially be viable. It wouldn't be cost effective. It wouldn't be time effective.
Exactly. Well, I don't want to have to spend tens of thousands of pounds on dies. This whole project for now has cost less than £500.
Unbelievable. and I think it's a great indicator of how modern technologies are leveling up manufacture. You know, in the past, to do that as a factory, you'd need expensive machinery, or to do it, you'd need to purchase expensive dies and mold tools. And really, I think having that a bit, I can't believe how low that cost is still, but
it's still wild, isn't it?
Ability to make that accessible to everyone is a game changer, and I can only see that really accelerating technology, design, advancements, innovation, because it's logical that now, if it's accessible to everyone, really opens up that opportunity where independents wouldn't have necessarily had that access to drive it, and it would have been potentially prohibitive and sometimes, you know, prohibitive to say the bigger companies. You know, we talk about NASA with TRLs. You spoke about that before. You know, it's brilliant you can, in principle, compete with NASA from home.
Well, yeah, at the scale of these small drones for now, yeah. But I think part of where we're at I think there's a lot of cultural work we need to do in the space industry over here to get them to the point where like building space planes are viable and all this. So if we can go through and build like small test prototypes like this, where we can test flight controllers in the background. I don't know whether you can see that there's a helmet somewhere. If you can maybe see it back there.
Is it just at the bottom? Yeah.
Very at the back. Yeah. That's a helmet we're working on for some of the XR work. We've got this. You might not have seen this actually. This is a heat shield that we're working on.
Outstanding.
So it's a fabric.
Yeah.
Entirely 3D printed, like a chain mail. But we're using magnets on the back to affix it to a hull, for example. So it's it's like how do you like improve the maintainability of something where you're trying to do multiple flights per day? Like if you need to pull off these tiles, like how do you make that as easy as possible for
I think that's a brilliant example. I love heat exchange through additive, the ability to create the complex geometries and maximize surface area, and have a hot and cold side. Even if we were 3D printing that as an industrial material, it's really easy then to put a hot side and a cold side, a material that dissipates heat much better on one side and keeps the heat much better on the other. We call it graded, essentially.
Yeah.
We can do that material, which we could never do before without actually manufacturing different assemblies and putting them together. So it's a brilliant example, and I love that fabric. I have a swatch on my desk that's different.
Okay.
It showcases the capabilities of additive manufacturing. And I think it's great you talked about XR there. Again, additional skills from the course. We're going to use simulation. We're going to use computer simulation. We're going to use AR and VR to really sort of get into the immersive world and see whether these things work for acclimatization, for risk mitigation, certainly around some of the high risk activities. And it's brilliant to see how all the different capabilities of Industry 4, which are a system, are coming together in what you're doing. It's not just the 3D printing, it's the whole gamut of
the whole gamut. Yeah, but that's the whole point of being a frontier development lab, is that we're pulling in all this technology towards us, so we can then act as a point of contact or an expert in residence for other companies.
Outstanding. And I think so it leads us nicely that where do you go from here, to the
Well, I've got on a little bit more of our advanced side. I just want to show you a couple of things. Let me grab this.
Great.
I should manage this cable at the same time. This magnet's a bit strong. It's like my fishing magnet. They do magnet fishing.
Yes.
But it holds onto these. So these are some magnetic bowls.
Yes.
So all of these magnets are pointing inwards.
Yeah.
So it gives you the capability to have a monopole magnet, which you can't have. Like if you split a magnet in half, you end up with two magnets.
Yeah, it's always got to be two. Yeah.
So because we're able to manipulate the geometry with specific 3D printed forms,
brilliant.
You can point the geometry in a specific way and emulate it only having one lobe. So we combine those two together and create a chamber that inside of here, you've got mirrors on the end. Inside of here, there is a small tritium vial.
Yeah.
Because we're looking at handheld microfusion reactors, but that is a long way off. That's just
it's outstanding.
That could be a whole different thing.
That is outstanding. And when I look at that, what obviously jumps out is a fusion reactor. As soon as you've got that item floating in space that's suspended, all of a sudden you have we can change the laws of physics to a degree. We can do different things that we're not able to do. And it's brilliant as you've used additive to create that geometry.
Well, there'll be no other way of doing it. Because specifically, you've got to get the alignment of these magnets like bang on, and there's just no other way of doing it.
Outstanding. I mean, it's a brilliant piece of development. What can I say? I know there's a lot of time, effort, and money looking at space batteries. And again, as an open source community and project through Supernova Labs, I see you competing with some huge engineering companies who, these capabilities and beating us, you know, perhaps aren't as far forward with you in your development, to be fair.
Well, but this is it. Like, there's a lot of things that are at different phases of development. Some that aren't working, some that are working. So I think what they're probably better at is coming up with projects that can get to the end of a thing and are working. We have a lot of open loops here.
I think if you follow a lot of innovation and development, the phrase "fail and fail fast" is really important. It's important to know what doesn't work, and I think the ability there to make those really cheap 3D models. I can see there's a few grams of filament there. It's a few pence, if that, to make
exactly.
that.
This is it. At such a small scale, like we can just keep like churning out like small little demonstrators that give us the core learnings for something at a much larger scale. So just to give you an example, I've been looking at SDFs, so sign distance fields for manufacturing. We were talking about bone structures. This is the one of those bone structure style heat exchangers. Typically you're supposed to print this in metal.
You prototype it here.
Prototype. You can just.
I think it's brilliant. As someone who's used and designed a lot of heat exchangers, and we obviously use them extensively through the nuclear industry. One thing that jumps out around additive manufactured heat exchangers is the massive increase in performance that isn't physically possible using traditional manufacturing. And what you've really demonstrated there is how to get a massive surface area out of that piece. Before we create the metal one, you're proving the point, you're proving the surface areas, you can prove that heat exchange for again a few pence and at home, you know.
Exactly, this is it. Yeah, there's one last thing I want to show you. So we've been looking at testing engines. So I don't know whether the model there is a model in here somewhere. I need to go and find that. But I've been designing an engine for our space plane, and this is it on top of a Coke bottle lid.
Brilliant.
Because
it's rocket science, Adam.
Well, because it's quite easy for us. You can see inside of here with whether it's on any focus on that.
It's like thread,
We're able to not just all the holes, so you can engineer the size of the aperture to emulate a much larger scale thing. But on whoosh rockets, you ever heard of these, where you just put a little bit of ethanol inside of a 2-litre bottle, barbecue lighter, and just pop that off, which gives you the high exhaust gases enough, and you can do that over a long frame rate, just enough to get some of the fluid mechanics of how
absolutely.
But this is an engineering model on top of that.
You can see that you've just hit the nail on the head. The ability then to see those fluid dynamics, what's happening, and again iterate, see the fluid dynamics before we go to these, higher cost production parts. So again, incredible, really, really incredible work.
We've got to be resourceful here.
Especially given, that independent open source nature of it.
Yeah.
I just think it's fascinating, and I think it's brilliant you've been able to apply all these things, and the outputs I can see are amazing, and I'm sure there's a lot more you can't talk about.
There are things,
Really impressive, and I think it's a great inspiration for many that what's possible, the art of the possible through something quite simplistic, really, relatively as a piece of equipment and as skills. But what that opens up is incredible. Your work is really impressive.
Thank you, Paul. That's very good. Very grateful. It's very kind.
Just one more question to ask, really, and it's great. Would you recommend the Skills Bootcamps program to other people? I think it's a good question.
I think it's necessary, actually. Part of the reason I came on it in the first place is we've advocated for this kind of training for a long time, and it's great to see a company applying it. Because I think there's a lot of companies in the UK that are maybe holding on to older ways of manufacturing, older ways of approaching manufacturing, where the rest of the world is moving far, far away from it. In terms of lights off manufacturing, just running through tools, because the tools are cheap. A lot of guys in the manufacturing industry with their milling machines, they're still taking like 0.5 mil depth of cut. It's we need to be faster than that.
We do. We need to be better and more efficient. And it's brilliant you mentioned sort of subtractive manufacturing there and traditional. It's brilliant you mentioned lights off and automation manufacturing, because with the best will in the world, that is where we're going. You know, we need the efficiencies, we need to, you know, de-risk some manufacture and bring, you know, the health and safety aspect of not being involved in that and letting the machine do all the heavy lifting is huge. And I think it's great you've been able to apply this. You know, the program from the Department for Education is a brilliant program, and there's lots of different sectors we can do this in. And it's great getting that feedback that on the ground is having real impact to the every person, to the
100%,
who can really benefit from these types of program, and that's just really encouraging, you know, for us, and that's what gets us up in the morning. I think it's brilliant to see real world applications of it.
Yeah, and specifically, well, I finally managed to get a meeting with Airbus. So if you're coming down to the next Constellation event,
yes,
we're all going to Airbus's site for the first time. They probably properly opened their doors for the entire time I've been coming there. So this would be a really good opportunity to like get a full view of what they're doing.
Brilliant, and especially given your knowledge now of the sector, your knowledge of the terminology, your research and development you've done. I can see that being of real interest to companies like that. When you are in that room, you get one chance, you know, and you've got to take time. And what's come across from this chat we've had is just how much your depth of knowledge, your depth of progress that you've made is brilliant, you know. And as an engineer in my own right in advanced manufacturing, if we were having this discussion in a room at Airbus, I'd be asking you back in for some more discussions, and we'd be having further chats on that. And I think that's really encouraging. It's impressive, Adam. You know, let's be realistic. It is impressive. You know, I'm not just saying that. It is really impressive what you've done, progress, the work you're currently doing, and I just can't wait to see where you go from here with it. So obviously stay in touch, and we'll probably catch up at that Constellation event, I'm sure.
Well, yeah, the Constellation event, especially you were talking about the biomimicry stuff with your guys in house as well. We should have a long chat about that, I think, at some point.
Yeah. What we'll do, we'll catch up offline on after this, and then we can have a discussion about where we can, you know, perhaps help you there as well. You know, we do have going support and wraparound support, and again, it's brilliant to be involved in these things. It's brilliant to be cutting edge and dynamic and shake up sectors and shake up industries. You know, that's what the sector has capability to do.
Yeah, and chart entirely new courses.
With your drive, have the capability to do, and it's brilliant. You know, I see a brave new world out there, and you know, you're a massive champion and advocate of that. So
yeah, well, I wouldn't be here at all without your support. So thank you.
You're a gentleman. Well, thank you for taking the time to have a chat with us this afternoon. It's been really enlightening seeing your progress and Supernova Labs. So we really appreciate it, and obviously the best of luck going forward with it.
Smashing. Well, thank you very much, Paul.
Thanks, Adam.